All right, this is a continuation of section 2.5, 2.6. We're on example 3. And yes, you can see these get a little bit harder. And it's slightly different. So what my eyes are catching is like, look at the difference between A and B here. There's a slight difference, right? And I'm sure you're capturing it as well. So let's just kind of walk through these and learn what's going on with them. The first one, A, is one of our easier ones. What I hope you recognize, let me use a little highlighter here, is that we have a multiplier going on. And that multiplier then could look like y equals 3/8 x to the 4th. And then this just becomes a really nice power rule. So we get y prime equals, bring down your 4. I'm going to show that, although, you know, if I were to do it normally, I probably would have just multiplied it through in my head. That's okay. We're just learning these techniques, and we need to take our time on them. And whoops, what did I mark? Okay, 3. We're going to subtract a power. So I brought down my 4, didn't I? And then I reduced the power by a degree. And now let's just summarize. I would have what? 3 times 4 is 12. 12 divided by 8. 12 eighths. 4 would go into both, so 3 halves. I also could have done this, and maybe some of you were thinking of doing it that way too. So either reducing 12 eighths, which is equal to 3 halves, or reducing 4 into 8 right away. That gives me an x to the positive 3. There's our result from example A. Example B, it is not a 3/8, is it? Because this 4 is outside the parenthesis, this 4 applies to both of them. Draw those arrows so you can see that happening, or remind yourself that that's happening. So 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is, oh yeah, 81. 3 to the 4th is 81 over 8. Now, like before, this could be written, I'm not going to go equals, I'm just going to rewrite a whole new statement. 81 eighths is our multiplier, isn't it? And now I can use product rule on this and get y prime, because I'm working on a derivative, so use the appropriate notation. 81 eighths times that 4 coming down, x to the 3rd, reduce the power by 1. And I'm sure, you know, I didn't show you the -1 because now we've done this for a while. You're probably getting annoyed with me showing the -1 each time. So 4 goes into 8 2 times, and my final answer would be 81 halves x to the 3rd. And I would prefer to leave it as 81 halves rather than writing 40.5 x to the 3rd. Have you ever seen that really written on a worksheet or in a textbook? No, it's not standard convention, is it? 81 halves would be the standard convention. Okay, I'm going to erase. And then let's take a look at C next. These can just stack up, maybe right up there. See if you can rewrite C. I see a multiplier, and I see an x squared in the bottom. Rewrite that. When I rewrite it, I created this. I said, okay, that's a 9/7, and then an x to the -2, because we know the advantage to writing it as a power with the negative, so that we can reduce by 1 in our derivative step. So we're on to our derivative here. Y prime equals 9/7. The -2 comes down, and then I get x to the -2 minus 1, so it moves to a -3. This is power rule. Now, let's take 9 times -2, get -18/7. X to the -3, then drop to the bottom. Not so bad. D. Ready for D? All right. Ooh, this is a little trickier. So, first thing I noticed, if you have a highlighter, why don't you highlight the fact we have an x in top and an x in bottom. There is a common denominator on this. And we can rewrite this as a 5 over x minus an x to the 4th over x, which will simplify, won't it? It gives me a y equals 5x to the -1 minus an x cubed. Power of 1 for that denominator, right? And it's when you have a quotient, you subtract the exponents. Now let's proceed with our power rule and get y prime equals negative 5 x to the negative 2, so we subtracted a power, minus 3 comes down, x to what power? The 2, absolutely. And final step is to make it pretty. Negative 5 over x squared minus 3x squared. And I'm not going to have you write this as a common denominator and bring it all together as 1. This will be satisfactory. All right, E. Oh, E looks interesting, doesn't it? Let's stack those up there. What's with this K? K is meant to be, I think in the directions up above, it says let K be a real number. Find the derivative of each of the following. So K is some real number. That means that these are our multipliers or the multiplying constant, the coefficient, all those words would apply, right? So how do I proceed on this? Well, I'm just going to do the power rule like normal. So I've got this 3K that I'm going to move forward. The 4 would come down on the x, and then it would move to a third power, wouldn't it? The derivative, this constant, let's say that this is a constant, that's C, which means it's just some number. The derivative of a constant gives us 0. All right, now let's summarize. We're going to have 3 times 4 gives us 12, order of operations, right? Or order of multiplication can be reorganized. So we get 12k x to the third, final answer. Yeah, we're just messing with you a little bit, throwing k's in there, c's in there. They could have put 5, right? And then the derivative of 5 is 0. They could have put 7, derivative of 7 is 0. Yeah. Okay, erasing that. On to the next challenge. Well, this looks super sweet. We got a pi, we got a k, we got a radical. When I look at pi and k, in my head I'm thinking, oh, these are just multipliers, they're just coefficients. They will be no trouble whatsoever. And the radical I'm going to rewrite. So I am going to take a moment first, before I do my derivative, and rewrite these. Pi, x to the fifth, minus k, x to the 4 over 3, power over root. P comes before r, power over root. All right, now let's do our derivative. Well, this pi could be brought out front, couldn't it? And then I'd have 5x to the 4th from power rule, minus k, 4/3 comes down, I get x to the 4/3 minus 1 would give me 1/3. Reduce by 1 degree. So I subtracted 1, didn't I? Excuse me. G prime. Well, maybe many of you wrote this down. We would probably put the 5 in front of the pi and go 5 pi x to the 4th. That looks like standard notation. And on this one, I would probably move the order 2 and put my 4/3, then the k, x to the 1/3. Or I could write it as a radical. The way to write it as a radical would be the 3rd root of x. Okay, I'm going to erase that. You're just getting all kind of oddball ones here today. For this one, let's expand it and make into a polynomial. So that's going to look like a y equals 3x cubed minus 6x minus 12x squared plus 24. Simplify. So we haven't done a derivative yet, so no y prime. Well, you know what, there's not a lot of simplifying, but I do think I'll select the order in more of a standard form notation. Why don't you hit pause, see if you can get your derivative right. 9x squared minus 24x minus 6. this goes to 0, right? 24 is a constant, it goes to 0. You can put plus 0 there if you want, and rewrite it without it the next time. That's all I have for you. Have a great day.